In this video, I'm going to go over factoring by grouping. And I think you'll find that this is exactly the same thing we do when factoring trinomials, except with one difference. The leading coefficient, this is the leading term in our trinomial, this is the leading coefficient, which is 2 in this case, is not 1 anymore. Now it's obviously a 2 this time, but it's not always going to be a 1, nice and easy. But we have this standard form written out here for a reason. It's because we're going to take A and C and multiply them together. So in this case, A is 2 and C is 9. And we're going to get 18, right? And this time, we're going for the factors of AC, not just C. And we're going to look for those factors that add up to be B, which in this case is 9. Is 9. Positive 9. Includes the sign in front of it. But if you remember my previous video when I was going over factoring trinomials, we were just factoring out C, but A was just 1. So 1 times anything is just going to be the anything. So it's actually doing the exact same thing we were doing in the previous video. But in this case, it's a little more complicated because you got to multiply that by whatever A is. Anyways, factors of 18. Well, 1 and 18, that's one thing. But that adds up to be 19. That's not 9, so I need to keep going. 2 and 9. 2 plus 9 is 11. That's not working. 3 and 6. 3 times 6 is 18. 3 plus 6 is 9. Ding, ding, ding. There we go. That's a lousy star. There we go. That's still lousy. Oh well. We have our two numbers that multiply to get 18 and add together to get 9, 3 and 6. Now, what do we do with them? This time, instead of assuming that we're going to get one binomial times another binomial, we're just going to rewrite it, but with one key change. We're going to split that 9x into those two factors we found. This is what grouping is all about. Now, what's crazy is that we can group things together. This is the grouping part. We can take these two terms and just focus on getting the GCF, the greatest common factor, out of those, and focus on these two terms and just get the greatest common factor out of that one. So we're just taking, splitting this 4-term polynomial into 2 binomials that are being added together. See? So what's the greatest common factor of this? They have an x in common. That's it. X times 2x plus 3. Can't factor that anymore. 6x plus 9. Greatest common factor. Again. They don't have an x in common, but can we divide 9 by 6? No. Can we divide 9 by 2? No. Can we divide 9 by 3? Yes. We can divide 9 by 3, and we can divide 6 by 3. So 6 divided by 3 is 2x. 9 divided by 3 is 3. Now, if you remember my greatest common factor lesson, is that we have yet another greatest common factor. We just did the GCF here, GCF there, and now we're doing another GCF here. Where's that GCF? Well, we have, if you think of this as all one term because it's being multiplied together, and think of this as all one term, they both have a 2x plus 3 in common, don't they? So we can factor that out. 2x plus 3 times, what's left? X plus 3. The coefficients. And there's your answer. It's all factored out. That's what grouping is. You just kind of group those together, and you just take the greatest common factor, greatest common factor, greatest common factor, until it looks all nice like this. Now we can check that answer. 2x, by foiling this out, we can check that answer. 2x squared plus 6x plus 3x plus 9. That combines to be 9x. So we're good. That's what we started with, right? Yep. Now, there's one other thing I want to mention in grouping. Grouping is so nice because you see how I did this plus 3x plus 6x? What if I went back in time here and for some reason I wrote the 6x first? Would that change our final answer? This is the beauty of math. It would not change our final answer at all. Let's test that statement there. Group these two together, group these two together. Different, slightly different though, right? What is the greatest common factor here? Well, 2 can be divided by 2, and this can be divided, 6 can be divided by 2. And there's an x in common, so we have 2x, right? 2x squared divided by 2x is just x. 6 divided by 2 is 3. X divided by x is 1. So that's just x plus 3. Over here on this side, greatest common factor is 3. Greatest common factor. Coefficients. Same exact answer, slightly different order. Order does not matter because it's multiplication. Check our answer. Foil it out. X times 2x. 2x squared. X times 3 plus 3x. 3 times 2x plus, whoa, came out looking like a 7 there. Plus 6x plus 9. 2x squared plus 9x plus 9. Once we combine the like terms there. See that? The beauty of math. Order doesn't matter. What does matter is the signs. Positive and negative definitely matters. So I'm going to do one more example. And we're going to erase this because it helps us treat this like a test. All right, so my next example is 6x squared plus x minus 1. 6x squared plus x minus 1. All right. Take a times c, which is 6 times negative 1, right? So it's negative 6. And b is 1. So factors of negative 6 over here, and the sum of those factors over here. What multiplies together to get negative 6? Negative 1 and positive 6. Positive 6 and negative 1. Negative 2 and 3. Positive 2 and negative 3. Yeah. Add those together. 6 plus negative 1. 5. 6. I just wrote the same thing twice. That was weird. Negative 6 times 1. Negative 5. Plus 1. Yeah, negative 6 plus 1 is 5. Negative 5. Negative 1, negative 2 plus 3 is positive 1. 2 minus 3, negative 1. What are we looking for? We're looking for positive 1. B is positive 1. So this is what we're using this. Negative 2 and 3. So you just rewrite it. 6x squared minus 2x plus 3x minus 1. And we'll do that same test again. We'll see, 6x squared plus 3x. Let me get rid of this now that we have our answer. Minus 2x minus 1. We're going to do this both ways to prove that it doesn't matter which one of those you put where. Okay? Group them together. Oh. Might want to include the negative sign when you group them together like that. You're adding a negative that's the same as subtracting. So what I did there did not change anything. Just want to include the negative sign when I go about finding the greatest common factor there. It's just something I do to make sure I don't mess up the sign. Let's do this one first. Greatest common factor here can be divided by 2, both of these. And there's an x in common, so 2x. 6x squared divided by 2x is 3x. Negative 2x divided by 2x is just negative 1. There is no greatest common factor there. It's just 3x minus 1. That was easy. Now, here is the part that can be tricky. We're going to take the greatest common factor out of that right now. So they both have this 3x minus 1 in common, right? Whew, that's the first part of it. What's the second part? Is it just 2x? No. Do not forget, there is an understood 1 right there. It's 2x plus 1. We're not just distributing this to 2x. We're also distributing it to a positive understood 1. That can trip people up all the time. And when you check your answer, if you just put 2x there, you would not get 6x squared plus x minus 1. That's why we always check our answer. So let's go ahead and do that. 3x times 2x, 6x squared, 3x times 1, negative 1 times 2x, negative 1 times 1. Check. That's what we started with, right? Excellent. And just for funsies, let's do it the other way. Greatest common factor here can divide by 3, right? Also can divide by 3 and an x, 3x. 6x squared divided by 3x is just 2x. 3x divided by 3x is 1. Now, greatest common factor here. There is a common factor here, but it's kind of difficult to see, isn't it? There is a -1. We can divide these by -1. Why am I doing that? Just to make everything else positive. So take out that -1. And so -2x divided by -1 is just positive 2x. -1 divided by -1 is a positive 1. If I hadn't have factored out that -1, these two would not be the same, and this grouping wouldn't work. So either way, you're going to get the same answer, but maybe this might be a little more difficult for you, so you might be grateful that you did it this way. Put that -2 first, -2x first, but get the same answer anyway. So, greatest common factor, once again, is this 2x plus 1. So we'll take that out. And what's left is the coefficients. Now, I don't have to write that 1, actually. It's understood 1, just like over here with this understood 1. And look, same answer. 3x minus 1, 2x plus 1. That is how you do grouping. Only need to use that when coefficient is something other than 1. All right, thank you.